React 19 adds support for React compiler. Until now, we've handled memoization manually. We use React.memo, useMemo and useCallback to control re-renders and avoid unnecessary work. But that approach adds extra logic to our components and it's easy to misuse. React compiler changes that. Let's break this down step by step. Before we talk about React compiler, let's quickly remind ourselves what memoization is. Memoization means saving a computed result so we don't have to calculate it again for the same input. In this example, process dataset performs an expensive calculation on a large dataset, maybe millions of records. If we call it twice with the same data, it repeats the exact same work. With memoization, we store the result the first time it runs. The next time we call it with the same input, we simply return the stored result instead of recalculating it. That's the core idea. In React, we apply the same idea of memoization to components and hooks. Here's how rendering works in React. A component re-renders when its prop, state, or context change. When that happens, React will also update its child components by default. And any calculations inside that component will run again as part of that process. To reuse previous results when inputs haven't changed, React gives us three main tools. React.memo is used for components with pure rendering logic. A pure component returns the same output when its prop, state, and context haven't changed. By wrapping a component with React.memo, we tell React it can skip re-rendering it when its props are the same. useMemo stores the result returned by a function. That function runs again only when its dependencies change. If the dependencies stay the same, React reuses the previous result. This helps avoid unnecessary recalculations. useCallback stores a function reference. Without it, a new function is created on every render, which can cause unnecessary renders when passed to child components. It keeps the same function instance unless its dependencies change. Manual memoization means constantly thinking about performance, deciding where to use it, managing dependency arrays correctly, making sure references stay stable. It's easy to forget and just as easy to overuse. Instead of just writing clean, simple components, we end up adding optimization logic everywhere. That's where React compiler comes in. It analyzes your components at build time and automatically applies memoization where it's safe to do so. Instead of manually adding memo, useMemo, or useCallback, much of that work is handled for you. The goal isn't to change how you write React, it's to reduce the need for manual performance tuning. You focus on writing clean, simple components, while most of the optimization happens automatically behind the scenes. Let's see how that works in practice. I have a small demo app. It's a simple contact list. We can filter the contacts by typing into the search box. We can select a contact. And below the search box there's Show Selected Contact checkbox. When it's checked, the selected contact is displayed under the list. That's the entire app. Now let's look at the code. At the top we have a parent component called contacts.demo. It renders two child components, contact search box and contacts list. It also renders the checkbox and the selected contact block. Inside contacts.demo we store three pieces of state: the current search query, the selected contact, and a flag that controls whether the selected contact should be visible. Now, before enabling React compiler, I manually optimize this app. The filtering logic is wrapped in useMemo, so the list is only recalculated when the search query changes. Both callbacks that we pass to the child components are wrapped in useCallback, so their references stay stable between renders. Without that, new function instances would be created on every render and could trigger unnecessary updates in child components. And both child components are wrapped in React.memo. That tells React to skip re-rendering them if their props haven't changed. Now let's take a look at the show selected context state. Notice that it only affects elements in the parent component. So when we toggle the checkbox, it shouldn't cause the search box or the contact list to update. Let's open the browser DevTools. I added the console log to every component so we can clearly see re-renders. Now if I start clicking the checkbox, context demo updates each time, and we can see rendering context demo in the console. That's expected because we're updating state in this component. But thanks to the manual memoization we added, the child components are not re-rendering. Now let's remove React.memo from context search box. If we refresh and start clicking the checkbox again, we now see rendering context search box in the console, even though nothing related to the search box changed. That's exactly why we needed React.memo. Next, let's remove useMemo around filtered contacts. Now when I click the checkbox, contact list also updates. That happens because filter contacts becomes a new array on every render. The reference changes, so memoization no longer works. Now let's bring React.memo back to context search box. If we click the checkbox again, it no longer renders. But if we go to handle query change and remove useCallback, we start seeing rendering context search box again. So a new function reference is created on every render. And because React.memo compares props by reference, that new function is treated as a changed prop, which triggers error render. To avoid unnecessary updates, we had to manually add all of this optimization logic. Now let's see what happens with the React compiler enabled. But first I'll go ahead and remove all of the manual memoization. Now clicking the checkbox triggers re-renders in every component. To add React compiler to our Vite project, I'll go to the official React docs. First we'll install it as a dev dependency, so let's stop the dev server and let's run the command from the docs. Next, let's scroll down to the Vite section and let's also open the Vite config file in the project. We're gonna add the compiler plugin to the Vite React plugin configuration. So let's copy this object and let's pass it to the React plugin call in our project. Now we can start the dev server again. Let's go back to our app. I'm clicking the checkbox, and we don't see any console logs from the child components anymore, even though I've removed Memo, useMemo, and useCallback. Let's open the Components tab in React DevTools. Notice the blue memo badges. These components are now automatically memoized by the compiler, even the app component, because it can be memoized safely. So the compiler analyzed our components, it detected pure rendering logic and stable inputs, and it applied memoization at build time. We wrote normal React code, the memoization was added automatically. Now I have the same demo open in a Next.js project. In Next.js, enabling React compiler is very similar. Let's go to the official docs. First, we need to install the Babel plugin, so let's copy the npm version of this command. And let's run it in the terminal. Next, we need to open the next config file, and we need to add this React compiler true option to it. Now we can start the server again. Let's go to our app, and let's open the React DevTools. And if we search for contacts, we can see the blue memo badges. So just like in the Vite setup, memoization is now applied automatically at build time. Before using the compiler, there are a few important things to understand. React compiler is designed to work with code that follows the rules of React. These rules are very basic, and we should follow them anyway to keep our code maintainable and prevent errors, not just for optimization. For example, components and hooks should only modify local values. We should avoid side effects in render. Hooks must be called at the top level of a function component or a custom hook. You can read the full list in the official docs. I'll include the link in the description. If the compiler encounters code that may break these rules, or code it can't safely analyze, it simply skips optimizing it. It won't risk changing your app's behavior. React compiler also comes with an ESLint rule that helps detect code that can be optimized. If the ESLint rule reports an error, that specific component or hook won't be optimized. That's safe, the rest of your app can still benefit from the compiler. Let's quickly look at a couple of examples. First, inside contacts demo, I declared a variable called stats outside the component. It stores an object with the render count property. And inside the component, I incremented on every render. Immediately, ESLint shows an error. It says this value cannot be modified. That's because modifying a variable defined outside the component breaks the rules. If we check React DevTools, the blue badge is gone from contacts demo. The compiler skipped that component. Now if I remove the mutation, the badge is back. Let's look at another example. Inside contact lists, I try to modify the name of the first contact in the list. Again, ESLint reports an issue. This value cannot be modified. We're mutating props, which is not allowed. And once again, if I refresh, the blue badge is gone for contacts list. The compiler refuses to optimize it. If I remove the mutation and refresh, The badge is back. Now keep in mind, ESLint doesn't catch every issue. In practice, it flags some common problems, but it's not a guarantee. It's also important to understand the scope. The compiler memoizes React components and hooks, not every function in your codebase. And memoization isn't shared across different components and hooks. So should you start using it? React compiler is stable and has been tested in production, including at Meta. The React team encourages developers to adopt it. While it's optional today, some future features may rely on it. That said, rolling it out to production depends on the health of your codebase and how well you follow the rules of React. For new code, the recommendation is to rely on the compiler for memoization. For existing code, adoption should be gradual. There's no need to remove existing memoization immediately, so test carefully before refactoring. React compiler gives you fine-grained control over how it's applied. First, you can opt in at the component level using useMemo. That enables compilation only for that specific component or hook. Second, you can apply the compiler to specific files or directories using Babel overrides. Third, there's runtime gating with feature flags that allows you to enable or disable the compiled output dynamically, useful for gradual rollouts or A/B testing. And finally, you can opt out for a specific component using useNoMemo, which is helpful for debugging or isolating issues. Now let's see what this looks like in practice. First, let's look at opt-in annotations using useMemo. I have the Next.js project open. Earlier we enabled React compiler globally. Now we'll switch to annotation mode. For that we need to set the React compiler option to compilation mode annotation. So let's do that. This tells React to only compile components that explicitly opt in. Now let's go to React DevTools, and if we search for contacts, we can see the memo badges are gone. Nothing is being compiled anymore. Now let's opt in manually. I'll open contact search box, and at the very top of this component I'll add useMemo. Now if we refresh, we can see the memo badge, but only for this component. So now compilation is scoped exactly where we want it. Let's do the same in the Vite project. Inside vite.config.js we can enable annotation mode through the Babel plugin configuration. Let's copy the entire value of this plugins option, and let's replace the current array with it. And we get the same result. The memo badges are gone. And if I go to contact search box and add useMemo at the top, after refresh, we can see the badge appears only there. Now, instead of using directives, we can control this at the file level. With Babel overrides, we can tell the compiler to run only on specific files. For example, we could enable it just for the contacts list file. Let's copy this overrides option from the example, and let's replace the plugins option in our code with it. And we'll say src contacts / contacts list .tsx. And if we go to our app, we can see the blue badge is only added to the context list component. Or we could use a pattern to target all TSX files inside the context directory. Here we go. So adoption can be scoped by files or by folders, whatever makes sense for your project. There's also runtime gating. This lets you control the compiled output using a feature flag. So you can enable or disable the compiler at runtime. For example, rolling it out to a small group of users first. If you're interested in the details, the official docs go deeper into it. And finally, we can opt out using useMemo. The compiler is now enabled globally again, so all the memo badges are back. But if I go to a specific component and add useMemo at the top, after refresh, the badge disappears for that specific component. This is useful when you want to temporarily turn off compilation for a specific component while debugging or investigating an issue. So even with global compilation enabled, you're still in control. And that's the idea behind incremental adoption. So to wrap up, React compiler reduces the need for manual memoization, write simple components, follow the rules of React, and let the compiler handle the optimization. If you found this helpful, consider subscribing. Thanks for watching, and I'll see you in the next one.